Here is my high-level Boid. At the moment we have a blank screen. If you press the spacebar, it unlocks the mouse and you can move it around, which means you can move these sliders here. And these are our Boids. I've got it set so they go into wireframes while you're editing, and fly around it's WSD, Q to go up, go down, and you can hold shift to go a little faster. We're going to turn up the lure to center. So we can also adjust the three main flocking behaviors. So this will make them stick together a bit more and just sort of float around in a sort of flock. So let's add a few more points. So we've got a pretty nice upper limit. So see, those ones are going off by themselves because they've sort of already got a flock. So at the moment we're at a sort of cool almost 70 to 90 frames per second, but obviously the more Boids I add, the more that's going to tank because it's more processing. Yeah, it's pretty cool. We've got some flocks going on. They're all ECS architecture, which means I have a system that runs all my rendering, a system that runs all my behaviors, and a system that handles all my transforms. I've also got it set up so that instead of each model storing a model separately, I have it so that they store a number, and the render system has one model that they just point to depending on what their number is. That just switches everything in a way. I just thought that was a nice touch. Alright, so looking around, let's see if we can add any more. Yeah, we can add a bit more. It's starting to get into the sort of 10 frames per second area. So what I'm going to do is I'm going to turn on the... Instead of processing every Boid behavior every frame, because we might... At the moment we're sort of over-calculating. What we can do is calculate the first 200 on one frame, the next frame calculate the next 200, the next frame calculate the next 200, and just keep applying the forces. So what that does is it increases performance if there's a lot of Boids, but it also reduces the accuracy of some of the forces. I'll just demonstrate it quickly so you can see what I mean. So at the moment we're on 10 FPS, and turning that on, yeah, we're climbing up, everything's looking a lot smoother, but they're also being drawn to the center a lot more. So yeah, we've got now 1,000 Boids. We're going to pull them towards the center. Oh my gosh, it's too many Boids. You can see them all flocking towards the center. It's all looking good. And that adds little obstacles to the scene. And if you look here, the value that this is affects the minimum value this is, so that you can't have less entities than obstacles, and you also can't have more obstacles than entities. So why do we do this? This way, an obstacle is just a Boid that doesn't move. So all the Boids that are here will still avoid and sort of align away from them to sort of move around them. So yeah, all these values you can just adjust on the fly. There's very, very little performance hit whenever you change them because you're just changing numbers basically. There is collision detection. Whenever it detects a object in front of it, if there is a thing in that radius, it will apply a fleeing force in the opposite direction to sort of guide it in a way until it's facing the opposite way that it needs to go. Doesn't look like anyone wants to run into each other today. One thing I want to talk about is this red squid. Let's see if we can chase him. So During development, when I was implementing this obstacle feature, this red squid sort of turned up randomly. Initially, uh, it was sort of a bug, but I've decided to keep it in because it basically points to where the next squid that becomes an obstacle will be placed. Where did it go? Squid? Where's our red squid? There he is. So, if I were to increase the obstacle now, then the obstacle would appear where the red squid is. So yeah, it's a pretty straightforward system to use. You only want to turn on asynchronous partitioning if you're in the sort of 500 to 1000 boids. Any less than that and it doesn't really change the performance much. So this is the asynchronous partition system that I'm using. It gets the length of basically it splits the boids into fifth chunks, and then each frame it goes through a chunk, and then once it's done all the chunks it goes back to the first chunk and then the next chunk and the next chunk. And the way it does that is it just turns off all the big calculations that the Boid is doing. So this is what my flyweight system looks like. Yep, so you get a pointer to the Boid, you get the model matrix, and then if it's 1, you draw a black blooper, if it's 2, you draw a white blooper, and if it's 3, you draw an obstacle. Pretty straightforward. Let me show you what so this is a system, ECS, entity component system. Our systems are sort of separate to our entities, and they just take entities as an input and just loop through them, applying changes to the components that are stored in each entity. If I go over to my entity.h, I'll show you what an entity looks like. So all of our entities are stored in this array here. Which array? Yeah, we have an array of components, and this is what stores all of our entities. At the start of the game, we initialize an array of, say, 1000 of these structs, and each of these entities contains a transform, so a position. They each contain a model, a scale, a velocity, and a wander direction. Oh yeah, so instead of generating a random number each frame to simulate wander behavior, I have it optimized so that you generate a random frame, say every 1 to 2 seconds. You generate a random number every 1 to 2 seconds, and you just keep applying that number until you're ready to generate a new number, and that's more efficient than generating lots of random numbers. Okay, the other thing I wanted to show was the behavior stuff. So if asynchronous partitioning is enabled, we just set max boid to 0, and what that means is we just won't check any of our neighbors for this frame, which cuts down on the amount of calculations we're doing per frame. This stuff is just setting the model depending on if it's the black or white theme. Search neighborhood is the one we want to have a look at. So this is our collision, separation, cohesion, alignment, all that behavior squished into one search neighbors algorithm. And we just go through it. We go through all our neighbors, and if a neighbor is in range, we apply a force to all of these behaviors. And this bit here will make all of our behaviors affected by what our slider values are. And we add those in sequence so that the entity brain prioritizes behavior that should be more important. For example, separation before cohesion. What else did I do? This is the wonder behavior, so generating a new number or using the existing one if it hasn't elapsed its duration. It clamps the force and it adds the force to the velocity each frame, and that way we get that very smooth turning effects that makes the boids look as smooth as they do. So when we calculate collision, we are using a combination of the behavior that we use for wonder and what we use for neighbors. So we don't want to calculate collisions for anything outside a neighborhood because it's obviously too far away. We take the same point that we use for our wonder force generation, which is just a point along the Boid's forward axis. We just do a very simple radius check to see if there is a neighbor within, let's say the radius is 1, and if it is there, we apply a fleeing force in the opposite direction. What that means is the Boid will push itself in the opposite direction to hopefully make it face the other way, and then at that point it will stop pushing and it will be able to move on without colliding with the object. I have it set up so it uses the inverse to increase the magnitude the closer it is to something that might make it crash. Okay, this is all our sliders. This is all our systems. So we have a system for rendering, a system for behavior, and a system for our entities. Just going to get some more Boids just to show it working again. That's all our Boids. We can add obstacles. We can remove obstacles like so. Easy peasy. Our Boids will interact with them properly. We can adjust the speed. We can turn on asynchronous partitioning. Yeah. So that is my Boid simulation.